that the universe was empty or that the notion of nothingness ever truly existed. So how can we unravel this conundrum? How can we find a resolution to the paradox that the universe never really embraces the concept of nothingness? Let's delve into the fabric of reality and explore these questions in depth. What is nothing? Have you ever pondered the true meaning of nothing? Can nothing truly exist within the universe, or is it merely a concept confined to our human minds? Let's start by understanding the inherent nature of what we perceive as empty space. In a universe where the fabric of space and time is continuously expanding, nothingness becomes an elusive notion. The more we dig into the nature of the cosmos, the more we uncover a sea of energy, even in what appears to be pure emptiness. In the quantum world, particles spontaneously pop in and out of existence. These virtual particles borrow energy from the vacuum, only to return it almost instantaneously. This is not a violation of the laws of physics, but rather a consequence of the inherent uncertainty that governs the quantum realm. As a result, even when we attempt to remove every last bit of matter and energy from a region of space, these quantum fluctuations persist. They are a manifestation of zero-point energy, which means that a system at its lowest energy state still possesses some residual energy. The universe, it seems, refuses to be empty. From inflation to the present universe, the story of our universe begins with cosmic inflation. This rapid expansion phase is believed to have set the stage for the Big Bang, stretching out the density fluctuations that later gave rise to galaxies and large-scale structures. During inflation, the universe was dominated by a mysterious field energy. It was not empty. It was not nothing. As inflation ended, the field energy transformed into a hot, dense soup of particles. The Big Bang was not a creation event from nothing, but rather a transition from one state to another. The universe continued to expand, cool, and evolve. Stars, galaxies, black holes, and cosmic webs formed. Dark matter and dark energy, though still not fully understood, became critical components of the universe's makeup. Today, we perceive the universe as full of stuff. But even in the far future, when stars have burned out, black holes have evaporated, and the cosmos appears bleak, it will never truly be empty. Dark energy and the persistent zero-point energy will linger, ensuring that the universe never succumbs to absolute nothingness. Black holes and the curious case of Hawking radiation. The phenomenon of black holes further illustrates the universe's aversion to nothingness. Once thought to be eternal, black holes are now known to emit Hawking radiation, a process that eventually leads to their evaporation. This radiation arises from the complex interplay between the event horizon, the boundary of the black hole, and the quantum fluctuations in the surrounding space. The presence of the black hole's event horizon alters the vacuum state, causing radiation to be emitted. Black holes, therefore, are not static or eternal entities but dynamic objects that interact with the fabric of space-time itself. Their eventual decay reminds us that even in the most extreme and mysterious corners of the cosmos, the concept of nothingness remains elusive. Our cosmic horizon and the limits of observation. Finally, let's reflect on our place within this grand cosmos. Our observation of the universe is limited by the cosmic horizon, a boundary beyond which light from distant objects will never reach us due to the continuous expansion of space. This horizon not only constrains what we can see but also has profound implications for the nature of the universe itself. It reminds us that our understanding of reality is confined to our observable universe, a tiny fraction of the entire cosmos. Beyond our cosmic horizon, there may be regions with different properties, laws, or even entirely different universes. But such speculation takes us into the realm of metaphysics and away from the solid ground of scientific inquiry. The universe and the myth of nothingness. Our exploration has taken us through the intricate fabric of the cosmos, from the quantum fluctuations that pervade empty space to the enigmatic nature of black holes and the cosmic horizon. We have grappled with the notion of nothingness and found that it may be a concept that exists only in theory, not in practice. The universe refuses to be empty, always generating new forms of energy and complexity. The idea of absolute zero, of complete nothingness, remains an abstraction, a fascinating philosophical quandary rather than a physical reality. We have journeyed from the earliest moments of cosmic inflation to the far distant future where only dark energy remains, and in every stage, we have found that the universe is anything but empty. The realization that nothing doesn't exist in our universe prompts us to reflect on the nature of existence itself and challenges our understanding of reality. It encourages us to probe deeper, ask bigger questions, and continue our quest for knowledge. With that said, thanks for watching, and until next time.